Okay, hey, good morning, everyone. Let's see if we can get this going. My name's Joe Comps. I'm cyber threat analyst over at Valley Cyber. A little bit about myself, previously former Marine Corps, and then I shifted over to Air Force Special Warfare, did all that for about 14 years. And then recently I've been really focused on hypervisor security over at Valley Cyber. So today we're going to talk about ESXi and its inclusion in the new ATT&CK version 17. Kind of a lot of people are wondering a little bit, why ESXi specifically? There's other hypervisors out there. We're going to dive into that a little bit today. What I want everyone to do during this talk is kind of put on your attacker hat. Think like a bad guy, because that's what we're going to do. We're going to talk about some of the techniques. I'm not going to go over them ad nauseum. We all know them. We all love them. And the attack chains can be quite extensive, so we're not going to go through the full thing. But I'm going to give you a little bit of a bite size of what that looks like in the attack surface of ESXi and why it is so important. So, okay, why ESXi instead of anything else? Well, Adam did a great job talking about it yesterday, is that now we have threat intelligence and enough of it to where we can finally understand the techniques, understand what's going on, and start putting them on the framework. But why do we have that intelligence? Well, the reason is because the attackers are attacking it a lot more. It's kind of a chicken and an egg scenario where we can't really have MITRE ATT&CK unless we have people attacking things. So what we've seen over the past few years is that these threat actors, many of you have heard of, Scattered Spider or Octotempest or whatever name they go by. They've been wreaking havoc in the industries. They're causing an estimated around $4 billion in damage. But there's a lot of other attackers out there, a lot of other ransomware threats, and they're attacking these large name brands like Panera, Omni Hotels, Mark and Spencer's, who are, as of right now, probably poised to lose about half of their annual profits over this most recent attack. We're seeing APTs starting to target Supreme Courts and other government entities. And we're seeing a very, very massive amount of financial loss from these industries due to the significant blast radius of what happens when you compromise the hypervisor. Now, why that is that when you get on the hypervisor, and that if you have an infrastructure that's running ESXi and you're hosting all of your servers and everything on these hypervisor hosts, all you have to do is essentially that's that one button kill. As long as I compromise the hypervisor, I know that all my associated VMs are going to be encrypted just like that. We're going to go over that today. But another reason, okay, so they're attacking ESXi, but once again, why? Well, in case you don't know, VMware, or more recently Broadcom, whatever you want to call them, we're just going to call them VMware for now. VMware, they have about 84% of the current market share when it comes to hypervisors. Now, if you think about as an attacker, right, we want to think about from the perspective of a malware author. I'm a regular guy, I'm coding, I'm doing all these things with nefarious intent, but I have a family, I have hobbies, things I want to do. I want to ensure that my malware is going to have the most proverbial bang for its buck. So I'm going to write things that I know is going to have the most impact regardless of what environment I'm falling into. So that typically tends to be ESXi environments. So if my intention is ransomware, I want to write something that's going to be effective at conducting ransomware attacks. Now, the other unfortunate thing about ESXi is oftentimes in these environments, it's treated like an appliance. It's set up, it's configured. We don't really know a whole lot about it. We tuck it in the corner and we ignore it and we leave it alone. Well, unfortunately, this can lead to a lot of misconfigurations. This can lead to a lot of forgottenness, which unfortunately attackers love. So they'll do things like, they'll steal credentials and then go straight to the vCenter, or they'll compromise Active Directory and misconfigurations with ESXi that way, which we'll talk about a little bit later. We see other misconfigurations like secure boot is disabled, or maybe an administrator leaves SSH enabled. There's also no shortage of vulnerabilities that continuously come out on ESXi. And then really the only standard defenses otherwise, other than maybe some seams or some logging, is you have a firewall, which unfortunately is many times pretty easy to bypass. So these are the things that attackers are doing, what they're seeing, what they're focusing on, and why we're seeing a lot of attacks that are focused on ESXi. So, as we all know, the new matrix was added. In the enterprise matrix, you have ESXi. It's a lot of the same old techniques, because not a whole lot has changed. ESXi itself is kind of a Linux-derived hypervisor, so there's a lot of similarities there. However, there are some new techniques that we're going to go over today. And us within the hypervisor security environment, especially at Valley Cyber, we're really, really excited about this inclusion because we see that when attack moves, the industry tends to follow. And so we're really excited to see what the future of hypervisor security is going to look like with version 17 and beyond. So the first thing I'm going to talk about today is a pretty simple exploit. Right? This is based off of CVE 2021 21974. This is a heap buffer overflow, which is a two-stage exploit. It's going to start with information leakage, and then from there, memory corruption. Now, this affects a lot of the kind of older distros of ESXi. However, you'd be surprised how many environments are still running these older versions. Unfortunately, there is also a lot of exploits out there that you can just go and download off of GitHub that run pretty great, pretty easily right out of the box against these environments. So what we're going to do first is we're going to go on the hypervisor itself. This is the DCUI of an ESXi hypervisor. It's just the UI console. And we can see that we're on a 6.7 version. We go over to our virtual machines, and we're running our 3 virtual machines, Gandalf, Frodo, and Gimli, and we're a bunch of nerds over at Valley Cyber. And on the screen here, we have 2 windows. The window on the left is going to be our netcat listener. Essentially, that's going to catch our reverse shell once we launch that. We're passing the uname-tack-a command just so you can see when we get that connection. And on the right, we're running that exploit that we pulled off of GitHub. Now, when we run this, essentially all it's doing is it's sending bytes and packets of data to the hypervisor, trying to force that buffer overflow to start leaking memory addresses that we can start writing to. Now, the service that we're targeting is something called SLP, which it's troublesome, right? And I'll talk about a little bit more of that in a minute. So as we're leaking this memory information, really all we're doing in this exploit is we're just doing a simple backpipe, and we're using netcat because, believe it or not, it exists natively on ESXi. We're using netcat just to reach back to our other netcat listener to establish that reverse shell. So that's what we're going to be writing to the memory addresses. So as I was saying about SLP, the unfortunate thing about SLP is it kind of runs by default on all these systems, and also by default, it runs as root. So if I get remote code execution, I now immediately land on the hypervisor at a root access level. So what we're doing right now is we're still sending those packets over the wire, and we're trying to find that memory address information. It's going to run for a little bit. It's a bit of a lengthier exploit. But as this is going shortly here, we're going to see that we'll finally get some memory addresses that we want to write to. So there they are. We have the libc base address, the libc system address, and now things are going to start picking up a little bit further. We're going to continue to send those bytes over the wire. We're writing that make nod command, the temp, and the backpipe. It chews a little bit, and then here shortly you're going to see that uname-tack-a command pop over on the left, saying VM kernel version 6.7, and now we have our successful remote code execution on the hypervisor. So you can see there we are, 6.7. So now what we're going to do is we're going to run as an attacker, I have another server. I'm going to run a wget command. I'm just going to pull the ESXargs ransomware file over to this host, and I'm just going to launch it immediately. With that one-liner done, it's going to turn off all the VMs, because what I want to go after are those VMDK files to encrypt those. And I can list out, we're going to list out our Gimli VM here. And once I list out that file path, you can see the .args extension at the end of all of my VMDK files, and those are the virtual machine hard disk files. So at this point, it's pretty apparent that we as an attacker just had a good day because we now have a successful ransomware attack launched against this hypervisor. So if we go back over here, we try to turn on Gandalf. Unfortunately, we get that error message, failed to power on. We try to turn on all of our machines or any of the machines, and we're going to see that same kind of failed message. So now I've successfully launched ransomware against that hypervisor, and incident response and you defenders are about to have a really bad day. So here's the thing. When this happened, this was years ago, right? This is an older exploit. Well, why do we care? Well, at the time, Rapid7 ran a scan on the public-facing internet around 2023 and discovered that there was nearly 19,000 ESXi servers that were still vulnerable to this exploit on the public-facing internet. Well, you can do this today with something called Shodan, which many of us know and may love or may not love. But by, essentially it's Google for hackers, right? If you're unfamiliar with it, you can just put in the query ESXi, and you're going to see, actually this number, because I actually looked at it earlier this week, it's no longer 19,000, it's closer to 30,000 public-facing ESXi hosts on the internet. And as you can see, most of these versions, and I mean most because as I dig through the pages, I've yet to find one that's above 6.7. So pretty much all the ones that I've seen are vulnerable to this attack. So bad day, right? However, there are good news. If at all possible, patch your systems, right? Easier said than done. As we can see, that still patch management unfortunately seems to be a problem for much of the industry, which there's a lot of reasons for that. But another easier one is ensure that your network is segmented. Google Mandiant, they talk a lot about ESXi, and they've said often that you should treat the ESXi servers or you should treat vCenter itself like a tier 0 asset. Treat it like you would a domain controller. You want that to be protected. You want that shored off. You want that guarded. So if it's facing the internet and a login page right there, it's asking for trouble. So additionally, good news is the SLP service itself, it's really not all that critical. So you can disable that on the firewall, and you don't have to worry so much about this exploit because it's a non-critical function. Okay, so let's say you've done everything right. You have your network segmented. You don't have your hypervisor out there for anyone to see, but it's still getting attacked. And why and how? Well, what we're seeing a lot lately is, as industries start to shift a little bit more to these cloud environments and based off of these logins, we're seeing kind of an uptick in social engineering, highlighted by groups like Scattered Spider. They love using social engineering. We all know that, right? So they're using this to gain that initial credential access. This happened in MGM casinos, which has resulted in about $100 million plus loss. But we're also seeing other ransomware campaigns that are leveraging these kinds of attacks where they get that initial access via social engineering, and they find other ways to pivot into the hypervisor environment, whether that be vCenter or directly on ESXi. And what we're going to demonstrate is something called ESX admins, which is kind of an Active Directory authentication bypass, which occurs when you have your ESXi hosts connected to a domain, which VMware recommends you don't do, but in some cases you may have to do. So an example of what a lot of these attacks look like, and this is kind of Scattered Spider's older techniques, is they'll target the IT admin. Like the talk we had yesterday, it's not breaking, it's nothing new. It's all the same techniques kind of over and over, but they're going to target the help desk. They're going to target the admin. They may do a SIM swap, or they may do something like using the open source social engineering tool, EvilJinx, where they're just going to capture session tokens, capture logins, things like that via standard phishing techniques. But one way or another, they're going to get into your environment via some type of credential access. From there, they're going to kind of do their standard thing where they're going to pivoting. Maybe they'll compromise the domain controller and dump creds. Maybe they won't. Maybe they'll go straight to the ESXi environment. But regardless, if ransomware is their game and they're not just trying to do some kind of data exfiltration, then they're probably going to end up landing their way on the hypervisors. Now, I've spoke about it a couple times. If you're unfamiliar, vCenter is just it's the management plane for these ESXi hosts. So it's just kind of a one-stop shop, a login page where you can manage a bunch of different VMware ESXi servers that are hosting all of these VMs. But what we're going to do now is we're going to demonstrate what happens when a attacker, they compromise, they get their initial access, they kind of have that foothold, they compromise a user that has mid to low level privileges. This user is a domain user that is able to create a group in Active Directory, right? So this user is Billie Jean. We're going to go ahead and RDP into Billie Jean's box. And from here, there's an unfortunate misconfiguration that exists to where all Billie Jean has to do is create a group called ESX admins. They create that group, and what they're going to do now is within that group, they're going to add themselves to that group. And now, unfortunately, the way that things are set up by default, once that group is created and that user is added to it, and they apply that, we can go ahead and exit our RDP session. And as the attacker, we've got those credentials. We're just going to go over to the hypervisor, and we're just going to log in with those credentials, because all you have to do with this unfortunate kind of misconfiguration is if that group exists and someone is in that group, unfortunately, by default, they have administrator access to the hypervisors. It's something that VMware is aware of, Microsoft's aware of, but it exists in lower versions, but it still exists. So we have a similar situation here now where we have the VMs, Gandalf, Frodo, and Gimli. Interestingly enough, you'll note that Billie Jean, even though they have access, is not a member on there. But they can go and they can now edit the root user. They can change their credentials. So now they go in and they put their password to whatever it is they want at this point. And they're going to go ahead and once that's done, they're going to shift over to services and they're going to activate SSH on the box. So even if you have it set up right and your environment's right, they can just go in with their credentials. So now the attacker SSHs into the box. They use the new credentials that they just changed for the root account. They're going to maneuver back over to the Gandalf machine, and you can see we have our VMDK files, our VMX files, all those things for that virtual machine itself. And now they're going to do something that is different, which is new, but it's not, right? It's just living off the land attacks, formerly known as fileless malware. But what you're seeing right now is a ransomware attack. What this attacker is doing is a one-liner. They're just grepping for all the VMDK files associated with a certain VM. They're using OpenSSL, which also exists on ESXi. And they're going to encrypt all the files. They're going to use RM to remove all the files, and they're just going to append a little nuclear symbol to the end of all those files. And just like that, it's done before I even got to finish speaking, we've launched a single line living off the land ransomware attack against this entire hypervisor, simply by a little misconfiguration in Active Directory. So, this is also also troublesome. It can be fixed. There are patches that exist for the newer versions of ESXi. So if at all possible, please in your environments, if you're running it, upgrade to the newest versions. If you can, segment off that ESXi host, like we said. Even in your internal network, you shouldn't have any sort of underprivileged users having access to that. But at Valley Cyber, we really think the solution and that we offer is runtime protection, and that's really if you can put that on your hypervisor, that's the best option that you have right now to protect yourself from these kinds of attacks. So the final one that I'm going to go over today, it's a little bit more complicated, but it's something that we've seen a number of times, and more advanced threat actors like APTs will utilize something known as a malicious VIB. Now, VIBs are typically, what, at least on the threat intelligence side, what we've seen are used for persistence. What I'm going to demonstrate today is another ransomware attack. But it's definitely something that you as defenders want to be aware of if you are running ESXi in your environments. So what we're going to do is we're going to say, once again, all right, now you're running a newer version of ESXi. And unfortunately, the attacker was still successful. They've gained their credential access. They land on the hypervisor. They've enabled SSH, but they're going to go in, and what they're going to try and do is import some malware, and they're going to try and launch their ransomware attack as before. So we're going to SCP the file over to the hypervisor. We're going to log in with our root access. Once we do that, we're going to list out, and you can see ransomware at the very top, and we're going to try and launch that. However, it didn't work this time. We get an operation not permitted, and if you look at the logs on the right, it mentions something about ESXi exec installed only. Now what that is ESXi's secure execution policy. It's a pretty cool security feature, and it's enabled by default on the newer versions of ESXi. But when this is activated and when it's utilized, the hypervisor is only going to execute software that has been installed via something called a VIB, right? Now, what a VIB is it stands for a vSphere installation bundle. Now what that is it's just a software package. It's a format that's used by VMware to distribute things like software, drivers, updates for all the ESXi hosts. Now what VIBs are is they're really just like a tar gz zip bundle that contains XML configuration metadata, kind of like what we see up on the screen. And this metadata describes things like layouts, version numbers, et cetera, and they package this configuration data with the software that they want to install, and they kind of send that typically with a signature on that, right? There's a bunch of different kind of signed versions of VIBs, which we'll talk about here shortly. Now, unfortunately, the attackers can fake this information pretty easily, which is what they've done here. They've went ahead and they've created a malicious VIB. They have all the kind of fake metadata in there, and then they package that with the ransomware that they want to install. So once again, they're going to try and SCP this malware over to the host. They're going to SSH in, kind of the whole rigmarole, and then from here, they're going to use a tool called ESXi to try and install this software on the host. Now they're going to be met with an error message saying this violates extensibility rule checks. Okay, fine, whatever. They're just going to go in and they're going to append ATT&CK to say we want to force this install. Now in some instances that may actually work. However, thankfully for the defenders today, this one doesn't work because now they're stopped by something called acceptance level. Because the VIB that they have is a community signed VIB, which is not compliant with the current version, or excuse me, the current configuration that the ESXi hypervisor is running. So, okay, what they're going to try and do is an attacker is persistent, so they're going to try and change that acceptance level on the hypervisor to something called community supported. And now, once again, they're stopped in their tracks. It's three times they've been stopped in their track. So it's a good day for defenders, right? Well, not so much. So what acceptance level is, and I'll talk about this briefly, is essentially every time there's a VIB that's signed, there's levels to it, right? There's a VMware signed one, which says this is a software package that VMware signed. They're going to sign it with their own private keys so that the community knows this is something valid that we can install. There's partner supported, like we see here, which is an authorized partner of VMware. When they create software that is supported on ESXi, they sign it with their keys. Now, community, anybody can create and anybody can sign. So that's why we're seeing this not working here, because the acceptance level that's currently on the ESXi host is saying that, sorry, this doesn't pass your validation checks. We're not going to let you change this. So in order for the attacker to succeed in installing this malicious VIB, they're going to have to find a way to change this acceptance level on the host. Now they can do this by dissecting and abusing that ESXi binary that we previously tried to use to install the VIB on the host. Now ESXi, which is that command line tool, is at its core, it's just a Python script that anybody that has access to the hypervisor can read the source code. Now if you read that source code, you're going to find a function in there called advanced config. Now what advanced config does is it changes something called the config store, which is just, that contains an in-memory JSON called the acceptance JSON. And that acceptance JSON is what contains the device settings for things like the acceptance level. So now what we're going to do here is the attacker knows this because they're a little savvy, and they're going to find a way to change that. So we check once more. We see that it's currently partner supported with ESXi, and all the attacker is going to do at this point is they're going to just overwrite that acceptance JSON and say, hey, change it to community supported, please. And it says successfully completed. Sure, no problem. We'll go ahead and do that. Now we try to install, we check it one more time, and we can verify that yes, we have now changed the settings on the host. Despite secure boot, we just overwrite that JSON file, and now it's community supported. So they're going to try and install that VIB one more time. And it takes a little bit to chew, but operation has finished successfully. And now we launch our ransomware, targeting it at the data store directory. And we can see when we list out that file path there, that all of our VMs that are hosted in that data store have the .akira extension dependent to them, and we've used a malicious VIB to install ransomware, launch it, bypass the things like acceptance levels and validation checks and all that stuff. So you'll hear some people say that as long as you have exec installed only, you're good, or as long as you have your acceptance level right, you're good. But unfortunately, that's just not the truth. There's a lot of things that attackers can do that may take them some time, may not take them a lot of time, to bypass many of these just native protections on ESXi, which is why we highly recommend that you do all the things we talked about previously. We recommend that you go into MITRE ATT&CK, you look at the mitigation strategies that Lex has been working hard on. You do these things, but we also recommend that you find some type of runtime solution like the one we offer at Valley Cyber to really protect those hypervisors. And the resilience, there's a lot of ways that you can protect it, and I kind of mentioned all these things already and more, but it's definitely an appliance that is neglected, but needs a lot of work and a lot of security. So I also encourage you, if you have the time, if you're running ESXi in your environment, just take the time, check to see if it's on Shodan, check to see your configuration settings, check to see if like SLP is running on your service. Do all the things that make it hardened for criminals to actually go in there and try and get on your systems. So with that, I want to thank everyone for your time, and I'll move on to questions or just move off.
Very nice, Joe. Thank you. Yes?
Most of what I've read about these attacks is what you showed, which is just shutting down the machines. Are you seeing any exfiltration attempts? Because obviously that's a big trend. You exfiltrate the data so you can threaten to leak it out later and put more pressure on, but this is mostly talking about just disruption. So are you seeing any of that activity?
Are you seeing exfiltration attempts in these attacks on ESXi?
Yeah, so great question. I will say that the majority of the attacks that we see that target ESXi are ransomware. However, there have been instances, and Mandian put out a great one about talking about how sometimes domain controllers are going to be hosted as these virtual machines. So there have been attackers that will actually take the VMDKs from the domain controller, they'll exfil that, and then they'll set that up essentially in their own environment, and then dump the credentials and do things that way. Then there's also other instances where they may not. Once they gain that access, they may choose not to be so disruptive. They may decide to persist, which is, there's more data out there by Google. I think Lex wrote something as well about utilizing VIBs to actually stay quiet with an environment for a very long time. But to answer your question, yes, we do see more than that. It's just predominantly ransomware.
So Joe, your talk was like punching me in the face. And then telling me the difference between a haymaker and an uppercut. And then showing it in slow motion again and again.
Yep.
So as you conclude, would you go over once again the mitigations that you've observed that are effective in this? And pretty please, in order of complexity, like what's the simplest thing I could do to keep myself from getting Marks and Spencer owned?
Oh, yeah, well, unfortunately, complexity is the name of the game. But I will say the simplest thing is making yourself a smaller target. So just right off the bat, and kind of like in the order that we had them in those slides, and I did blow through them pretty quickly. But I will say patching is kind of number one. There's so many of these vulnerabilities, there's so many of these exploits that are out there just due to the fact of poor patch management. So we definitely encourage you, like, if at all possible within your environment, find a way to patch, or even like, virtual patching is an option too if you can't necessarily upgrade your environment. And then other things like network segmentation, things like that, ensuring that you have that tier 0 asset, the ESXi hypervisors segmented from everyone else on the networks. Those are kind of the two quick and easy ones. But then from there, it goes more into those configurations of the firewalls, of seeing if you can install things like a runtime protection solution. So
this is excellent. And you did share these countermeasures in your talk, and we have them in the mitigations of MITRE ATT&CK. So why do these attacks still work? Why aren't people doing these actions that you've so clearly laid out to defend themselves against 9-figure ransomware attacks?
I think a lot of it, as defenders, we take a little bit of time to catch up, to the curve. And when you have an environment that has so many different technologies out there, and you're focused on, maybe you're running AWS, or maybe you're running this thing or that thing, like it takes a lot of time to really go through and properly account for all of your systems. And unfortunately, ESXi has just been one of those ones that's been neglected for so long. But now that we are seeing that, attackers know that, it's the forgotten back door that we don't think about, and they keep going in there and they keep attacking it. Now people are starting to come around, and thankfully in the U.S. we see that those numbers, at least on Shodan, are slowly decreasing. But overall the numbers are still increasing. So I wish I could say exactly why it is, but I think it's just more of awareness than anything else.
Okay, well, thank you for bringing awareness to the folks in this room and the folks online. You have no excuse anymore. Thanks, Joe.
All right, thank you so much.